Welcome to this presentation called Classical Geometric Solutions, or the CGS series, presenting compass and straight solutions. My name is Kimuya M. Alex. And at this series, we look at solutions to 4 problems in the domain of classical geometry believed to be impossible for compass and straight edge constructions. Formerly, the ancient Greek mathematicians conceived the known problems of the trisection of an arbitral anchor, the cube duplication, and the squaring of a circle. These problems have proved to be elusive to many generations of mathematics and science, and they have persisted even to this date. Under this series, we will discuss about the problem of the angle trisection and that of cube duplication. I will also, in addition, give 2 more problems which involve the geometric construction of all the full-length angles and the solutions to the infinitude of the many regular polygons. For centuries, these 2 problems have been closely associated to the trisection of an arbitral angle, but I will discover through the presentation this has just been a misconception. To take us through the remaining part of this series will depend on the following items and the list in accordance. First, we'll do the angle trisection, and we'll be looking at the solutions to the trisection of an arbitral angle problem based on Alex Kimia's algorithm or theory or theorem. Second, we look at the cube duplication solution, or the duplication of the volume of a cube, and we'll be performing the geometric verification of the ratio 3√2:1 using the traditional Greek tools of geometry. Third, we look at how to construct all the whole-length angles and partitioning of an angle into the desired ratio. Then lastly, we'll need to perform the construction of the infinitude of the many regular polygons. And that is possible, of course, if we'll be able to perform the construction of all the whole-length angles, their ratios, their multiples and submultiples, it then should be possible to resolve the infinitude of the many regular polygons. And just for understanding what I mean by the regular polygons in this case, I refer to all the polygons that subtend an even valued number angle at the centers. That's what we'll be seeing through the presentations. There will be no arithmetics of any kind, just symbols, illustrations of the concepts. And I therefore refer you to the following reference materials for detailed information on how the concepts come up, the proofs, and the mathematics involved. The first item in our references list is this paper called the Angle Trisection Solution, and you can get a copy of this by typing Angle Trisection Solution into any internet search engines, published by the Journal of Advances in Mathematics. The aim of the paper was to refute one Searle's statement of 1837 that the solution to the angle trisection problem would imply resolving this algebraic cubic equation. This is just one of the misconceptions the guy had in proving the impossibility. We'll discover, and all through detailed discussions in the series about the angle trisection, that there are so many limitations or limiting aspects in the impossibility proof of the angle trisection problem. Get a copy of this for yourself. It's in open access. You will find very interesting discussions in here. And actually what I'm saying about the problem with the angle trisection impossibility proof of 1837 is captured from page 6, around page 5 of this material. Our second item in the list is the paper called the Cube Duplication Solution. This is how it looks like. Very short, elegant constructions in here. I have shown the geometric possibility of constructing the factor 1.2599 approximated to 1.26 for the purposes of proof. Again, as we will discover from the angle trisection discussion, the same logic is employed in disproving one Searle's argument or algebraic argument. You will also agree with me that the work presented in here is the shortest in terms of the number of steps, and simplicity in understanding. The article is also in open access. You can get a copy of this by typing the cube duplication solution into the internet search engines. Third, we look at the paper called The Possibility of Angle Trisection, published in the Journal of Mathematics and System Sciences in 2017 too. This paper begins by making a wrong statement according to the contents provided in the article. It is talking of trisection aptitude angle, but as you will discover in going through the presentation, the contents in here, it's performing the resolution of all the whole number angles and not the trisection of an aptitude angle. That is the misconstruction or the misconception many young readers are gaining in going through the one cell's impossibility proof of 1837. Many people think if you are able to construct 20 or another angle that's not a multiple of 15, we then should be able to have resolved the problem. That is wrong. That's not correct. And it comes from one cell's proof of 1837. Since he was unable to construct 20, he made a general statement. If we can construct all the whole number angles, then we should be able to resolve the angle trisection problem. That is really wrong. The proof of impossibility, as many would agree with me, just proves a statement, and a wrong statement for that matter. This article is in open access too. Get a copy of it for yourself. Enjoy the constructions provided. It's not complicated in any way. And lastly, we have this piece of book called The Angle Trisection Solution and Construction of Whole Number Angles in General, as published by the Lambert Academic Publishing. This is a picture of me in the book. This item makes corrections to the misconceptions and corrections I've just pointed out, or the mistakes I've just pointed out in the previous items I've displayed. You can purchase this from the many online bookstores in the internet. It's such a nice book. Well, that's the end of the brief introduction to this series. I hope you enjoy viewing the subsequent presentations. We'll start with the angle trisection and follow the rest in the order as I have just shown in the contents list. Thank you very much for viewing. Please remember to like and subscribe to this channel so as to view those other videos. Thanks very much. See you in the next presentations.